Hello, today we're going to talk about physics. This video will totally be based on intuition, not on complex mathematics. We don't need mathematics to describe physics, at least not the overview of it. So, what is physics actually? Many scientists have stated that what philosophy was to ancient times is what physics is to modern times. So, in a way, we can say that physics is the modern philosophy. They both pose the big questions like how did the universe begin? What is time? Why does it only flow in one direction? Questions like these may seem simple, but they are the most perplexing questions ever asked. Let's get on board and discuss physics in detail. So, again, what is physics? Physics is often described as the study of matter and energy. It is concerned with how matter and energy relate to each other and how they affect each other over time and through space. Physicists ask fundamental questions like the origins of universe, how and what is it made of, how does it change, what rules govern its behavior. Physicists may be roughly divided into two camps: experimental physicists and theoretical physicists. Experimental physicists design and run careful investigations on a broad range of phenomena in nature, often under conditions which are atypical of our everyday lives. They may, for example, investigate what happens to the electrical properties of materials at temperatures very near absolute zero, or measure the characteristics of energy emitted by very hot gases. I think the value of absolute zero in Fahrenheit is minus 460 degree Fahrenheit, and if we talk about in Celsius, then it is 273 degrees Celsius. Theoretical physicists propose and develop models and theories to explain mathematically the result of experimental observations. Experiment and theory therefore have a broad overlap. Accordingly, experimental physicists remain keenly aware of the current theoretical work in their fields, while theoretical physicists must know the experimental results and the context in which the results need to be interpreted. It is also useful to distinguish classical physics and modern physics. Classical physics has its origins approximately 400 years ago in the studies of Galileo and Newton on mechanics, and similarly in the work of Ampere, Faraday, Maxwell, and Oersted 150 years ago in the fields of electricity and magnetism. This physics handles objects which are neither too large nor too small, which move at relatively slow speeds, at least compared to the speed of light, which is 3 into 10 raised power 8 meter per second. The emergence of modern physics at the beginning of 20th century was marked by three achievements. The first in 1905 was Einstein's brilliant model of light as stream of particles, that is photons. The second, which followed a few months later, was his revolutionary theory of relativity, which described objects moving at speeds close to speed of light. The third breakthrough came in 1910 with Rutherford's discovery of the nucleus of the atom. Rutherford's work was followed by Bohr's model of atom, which in turn stimulated the work of de Broglie, Heisenberg, Schrödinger, Born, Pauli, Dirac, and others on the quantum theory. The avalanche of exciting discoveries in modern physics continues today. Given these distinctions with the field of physics, experimental and theoretical, classical and modern, it is useful to further subdivide physics into various disciplines, including astrophysics, atomic and molecular physics, biophysics, solid state physics, optical and laser physics, fluid and plasma physics, nuclear and particle physics. It is better to divide everything like they do in biology too. The taxonomy it's called, I think. Thank you.